Now there's another type of equation. It's the same, it's a linear equation, but it's written in a different form. We call this standard form. And there's basically 3 or 4 ways to graph this. One easy way to do it is to solve for y. And in fact, if you're using a calculator, that's what you'd want to do. The good news, you go through the same 3 steps every single time. There is never a change. You got to get y by itself. See what? See the y? I want to get it by itself. So I have to get rid of the 2x by adding negative 2x to both sides. And then I have to divide by negative 3. Does that make sense to everybody? See what I'm going to do? Get rid of the x, and then divide by the negative 3. It's always the same 3 steps. Now watch him do it for you. You want to color code it? Be careful. When you add this, do not attempt to do this. You can't. You cannot take 2x and add negative 2 to it. You can, however, add negative 2x to both sides. That's your first step. What do we call that black equation? Has a name? Standard form linear equation. This, all of these equations were in what we call slope-intercept form. This is called standard form. You'll find out when we get to systems why it's called standard. Now I'm going to do a couple of things. I'm going to eliminate my x's because 2x minus 2x is 0. I am going to get negative 3y. Now I am going to make one little change here. I'm going to switch these two. Because whenever I have slope-intercept, I like to have the x's first. Now if I did this, I couldn't switch them. So I like to add, so I can put negative 2x plus 6. Now be very careful. Your next step is to divide by negative 3 on both sides. And you're going to be tempted to do this. Check this out. Divide by negative 3, that's okay. Notice I'm not dividing by negative 3y. I'm dividing by negative 3. That gives me 1y, doesn't it? But you see that's a 1 right here? Positive 1? That gives me y on this side. Now when I divide on the other side, don't do this. I'm going to do this in purple. I don't want you to do this. Let me show you what the problem is. A lot of people put this, and then they put the negative 3 in the middle. Now here's the trouble with that. That is a common denominator. This negative 3 is under both of these fractions, isn't it? Aren't you going to be tempted to cancel this 3 with this 6? So here's how you can avoid making problems, having problems with this. Instead of dividing by negative 3 like this, divide it in both parts. Go ahead and put it under both of them so that it's a common denominator anyway. That gives you positive 2/3 x minus 2. Now you can graph it using slope-intercept. Go ahead. I like 0. We call that the y-intercept because y equals negative 2 when x is 0. Right there. And I've got a slope of 2/3. That's up to over 3. You can read it that way. It's up to over 3. Up to and over 3. Up to and over 3. And I have a slope of 2/3. Now you can do your problem this way, but you have another option. And I like this one better, and you probably will as well. It's a lot less work. I'm going to do the same equation, 2x minus 3y equals 6. I'm going to do it an entirely different way. I'm going to use what's called intercepts. And what I'm going to do, I'm going to pick a nice easy number for x, like, what's a nice easy number, guys? 0. And very important, I want you to write this down. Write 0 blank. Now remember up here, I had to do all of this to get this point and that slope, didn't I? But look how simple this is. I've got 2x minus 3y. Watch what happens when I put 0 for x. Don't I get negative 3y equals 6? Can you divide by negative 3 on both sides in your head? What do we get? That's going to give us a solution, isn't it? If x is 0, y is negative 2. Now I can do the same thing with y. Write the point first, or you're going to mess it up. Put the 0 in for y and write it down. Everybody messes this up. If y is 0, 2x equals 6. So what's x? 3. Here's an important idea. This makes this equation true, doesn't it? And this point makes this equation true. We call these solutions. That's what you're doing when you're graphing. You're finding solutions to an equation. All these points make this equation true. It just so happens that so do these two. Now, be careful. There is a mistake everybody makes. 0, negative 2, it's almost random whether people put it here or here. I'm going to show you a way to keep this straight. Does everyone see that this is a y value? Yes? It goes on the y-axis, and it's called a y-intercept. Seems kind of simple when I look at it that way, isn't it? Now watch the other one. This is an x value, and it is on the x-axis, and it is called the x-intercept. You have no idea how many people get that backwards. Seems kind of easy when I put it that way, doesn't it? Get that straight. So, 0, negative 2 is on the y-axis. It's right there. And 3, 0 is on the x-axis. It's the x-intercept. It's right there. And guess what? We get this line using just those 2 points. We can even count our slope. Can everybody see that if I count the slope from here to here, I go up 2 and over 3? You always count left to right. And there's your line. Your first problem is extraordinarily easy because there's 3 ways to go. And I'm going to do it all